How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today, we're going to talk about probability, and we're going to be doing independent and independent events. Before we start, please subscribe, turn that notification bell on. If you haven't, check the links in the description below or the previous videos about probability or anything on my playlist. Check them out. Other than that, let's get right into it. So, independent versus dependent. Independent is by itself, and dependent depends on something else to happen. So, over here it says, independent event is the outcome of one event, is when the outcome of one event does not impact the outcome of the second event, and that event is called independent event. And we kind of have like a formula. It says the independent probability can be determined by multiplying the probability of each event happening, or P parentheses A and B, and we can rewrite that as probability of the first event, probability of event A, times the probability of event B. Okay. Now, most likely these are going to be fractions on part over total. Okay. So the first example that we're gonna do, I'm only gonna do two examples, one for independent, one for dependent, because otherwise this video is gonna be too long, and I don't want this video to be too long. Straight up to the point. It says, on a board game, the students draw a card, replace it. This is the key term that is going to tell you whether it's dependent or independent. If you replace it, it's independent. Okay? If you replace it, or if they don't tell you, or they tell you that they're going to replace it, it is independent. They're going to draw a card, look at it, replace it, then draw a second card. Determine the probability of each event. So we're going to have to find the probability for each one of those things, part over total, simplify those fractions, and then we're going to multiply. So let's go ahead and look at what the card is. It says, to earn 50 points, a student must draw a heart eye card, then a anger card. So let's go ahead and look at the heart eye cards. So is the first of all, how many total cards do we have?
Yeah.
8. So my total is 8. So let's look at how many are heart eye. Is the first one heart? No. Second one? Third one? Yes. Right here. What about the fourth one? No. Next one? Yes. The next one? No. Next one? I'm sorry. No. And the last one? No. So how many do we have?
2.
So for the heart, we have 2 out of 8. Can we simplify this fraction?
Yeah.
Definitely. By 2 at least, right? So what's 2 divided by 2?
4.
1, and 8 divided by 2 is 4. So this is the probability for drawing a heart eye. 1 out of 4. You don't have to simplify at the beginning, but you will have to simplify at the end if you don't simplify first. Okay? So now I'm going to erase the marks that I made over here because it starts from scratch. And we're looking for the angry ones. Okay? I mean for the angel. Is the first one angel? No. Second one? No. Next one? No. Next one? Next one? Next one? Next one? No. The last one, that is angel. So how many do we have? 1 for angel. We have 1 out of 8. Can we simplify that? No. So we're going to put it right here. And all we got to do is multiply. And how do we multiply? Straight across. Not cross, across. What is 1 times 1? 1. And 4 times 8? 32. Can we simplify that? No. You can convert to decimal by doing table, but we're going to stop right here. Again, the first outcome has a total of 8, and the second outcome also has a total of 8 because we replaced it. Any questions so far? I'm going to give you guys a few minutes to work on questions 2, 3, and 4, and then we're going to come back and you can leave your answers in the comments below, and then we're going to come back and do dependent event. All right, so hopefully you left your answers in the comments below, but these are it. Basically, part over total, multiply them across and simplify if you can. Now, before we move on, if you did not get it, please stop and go back at the beginning, watch it over, and let's go ahead and start over dependent events. So dependent events is when what? If the first one did not matter, what do you think? When one of the events, when the outcome of one event the outcome of the other event, of one event impacts the outcome of the other event. So we have a formula. So the probability for these things happening, it'll be times the probability of B after A. That means do not replace. Okay? So the thing is that in this one it can get a little bit tricky because when we're not replacing, we gotta see what the second thing is gonna be, because we might be required to pull out the same thing, and then maybe we have less of that. The thing that is gonna change regardless is going to be the total of the second fraction and every continued other fraction. Okay, so let's look over here. We have a board game, and the student is gonna draw a number. They're not gonna replace it. That's the key part. Not replace it. Then draw a second number. Okay, we're gonna determine the probability for each event. I'm gonna do number 1 and number 2. You guys, I'm gonna give you time to do the other 2. Okay, so number 1, we have the board games. We have numbers 166, 92, 162. It says the question 1, draw an odd number, then drawing a 6. So the first thing that we gotta do is find the total. What is the total? My total is 8. Okay? Okay, so the first fraction, we're looking for an odd number. Okay? So how many odd numbers? Is 1 odd? Yes. What about 6? No. What about 6? 9? Yes. 2? 1? 6? And 2? No. So that's how many? No. How many total cards do I have? Selected. How many are odd? 3 out of 8. That's for the first try. Okay, can we simplify that? No. If we can, then we should do it. If you don't do it, you will have to do it at the end regardless. It's easier to do it now. Now, we gotta look at, we're not gonna replace the one that we got. Okay? We're not gonna replace it. And we're gonna assume that the one that we got is an odd number. Okay? So for example, my new total is gonna change. And if they ask for an odd number, one of the options is gone. In this case, they're not asking for an odd number, they're asking for a 6. So okay, so let's pretend that this odd number no longer there. Okay? How many total do we have now?
7.
We only have a total, the new total is 7, right?
Yep.
So we're gonna multiply. 7 is the new total, and then we're looking for what? Drawing a 6. How many 6 we have?
2. No, 3.
3. Can we simplify that? No. So can we multiply straight across?
Yeah.
Yes. See, no, my new total changed, right? That's, you gotta remember, if whenever they tell you that you're not gonna replace it, expect to change the total. Okay, so let's see. What's 3 times 3? 9. 8 times 7 is 56. Can we simplify this? I don't think so. This is going to be my final answer. So that's my final answer. Unless they want you to change to percent, this will be approximately 18.6 repeating percent when you do TiVo. Okay, now let's look at my second choice. I'm going to start with the blank set. My total is still what? 8. Okay? And they're asking. Yeah, because this is the second question. Okay? Number 2. It's a new game, right? Everything's back to the original. We're looking to draw the number 2. How many 2's do I have? 2 out of 8. Can we simplify that?
Yeah.
Which is going to be what? 1/4. Very good. Okay? So now, we're going to ask to do what? Draw another 2. We did not replace that 2. So that means that this 2 is gone. Okay? My total changed, didn't it? What is my new total? My new total is 7. So that's the bottom. But also, since I took the 2 out and I did not replace it, do I still have 2 2's? No, we only have how many 2's left? 1. There you go. That's the one that you got to be paying most attention to. When the one that you want, you pull it out and they're asking to get another one out, the total changes and the new, what you want also changes, right? So it's no longer 2 of them, it's only 1 of them because you kept 1. You still multiply straight across. This is 1 and the bottom is 28. Can you simplify that? Nope. That's it. Any questions today? We're going to go over that in a little bit. Okay, so I didn't want to go over this, but a prime number is a number that can be divided evenly by itself and 1 only. For example, 1, 2, 3, 5, 7, 11, 13, 17, 19, 23. And a composite number is a number that can be divided evenly by 1 itself and more than that. For example, 6. 6 can be divided by 6 to get an even number. 6 divided by 6 is 1. 6 can be divided by 3 and you get an even number. You get 2. 6 can be divided by 2 and you get 3. So that's more than itself and 1, right? So for example, if I give you the prime number 5. 5 can only be divided evenly by 5 and 1. 5 divided by 5 is 1, and 5 divided by 1 is 5. You cannot divide by anything else and get an even number, whole number. All right, that's what prime number and composite is. All right, so that's going to wrap it up for this one. We cover independent when you replace the card or the marble or whatever and the total never changes. And then we have dependent where you do not replace the one that you take out. So that means the total changes and depending on what they're asking, the part might also change. So at this time, if you haven't, please subscribe, turn that notification bell on. I hope that you learned something today. And other than that, that's going to wrap it up for this one. And let's ride.